Hey guys, so today we want to see how we can get new functions to be used within an Excel spreadsheet, so within the formulas that we define. The way we're going to do this is through our functions. So for all intents and purposes, basically we can either define ourselves an R function that will then be accessible in the Excel spreadsheet, or we can make use of the massive amount of packages and our functions that are already made available for us, and immediately use them in your or your colleagues' Excel workflows. So let me do a quick demonstration of what I mean. Basically, let's say we have a couple of tickers here. We want a custom function that is get want a custom function that will be get company names. We take in the ticker, and this now with this function, this will need to give us the name of the ticker that we've provided, the company name. It interacts with Excel in the exact same way you would expect. Pull down to fill works. So there's a lot more to this power, and we're going to see a few different examples of how you can use this. So let's start from the beginning. So what you need to install is BERT, which is the basic XLR toolkit. Interesting acronym, but yeah, flows off the tongue. We want to install this. After we've installed this, we can open Excel, and within Excel we can go to the BERT Console. It becomes a add-in. Now, I don't want to shock you, there's a couple of things going on here, and we'll go through all of them. Basically, BERT installs a separate R installation and defines a separate library, so there's no way of clashing with your current R installation or installed libraries. There's a benefit and a con, as we'll see short enough. So basically, you have here a R script of functions that are immediately sourced, and all of the functions that you define here are available under the moniker. So let's say we have the function get last price. We would do equals r dot get, and you see it there, get last price. So you can either define your functions directly here, or you can take maybe you already have a functions.r or some specific R script of functions, and you can place it in the folder where BERT pulls in the scripts, and that folder is in documents. It doesn't open like this. Can go to documents. We find it BERT2 functions, and basically we can paste any R file here, and those functions will be automatically loaded by BERT. So I've added here utils.r, which has a simple tester function, which is add 15, takes something and it adds 15 to it. Even though it's not open here in the BERT console, we can try it out to find it. So r.add 15, it's available there. Add 15 to 5, we'll get 20. So that's one thing. That's how you source your functions. So either paste them here or put your R script in documents BERT. So all the functions here are immediately available in Excel. What do we do if we want to use pre-made functions that are in packages? Now here it gets a little bit complicated. So BERT is very well done. However, the developer is not super active in the last couple of years. So because an R installation is already packaged into BERT, here you're running R 3.5, which is not such a out-of-date R, but I mean it's not the latest. So if you go here in the console, in the R console, if you do install packages to install something that you need, and you will need to install everything because you're starting with empty library. What you can do is run this code, which I'll provide in a GitHub repository along with everything here. So this instructs, we can do select, execute selection. This instructs this R to use this Microsoft MRAN snapshot from 2019, which is the latest snapshot for R3.5 and the other 3.51, 3.52. And this basically guarantees that you will not have issues installing new packages. Now, this is from 2019. Does it have the latest and greatest packages directly on CRAN? No. However, it has the basics and the tidyverse and whatever else, let's say the core packages. If you want something later, in any case, you can install remotes or DevTools and install stuff directly from GitHub. So that's one important thing to keep in mind. Run this so that you don't have problems installing. Some things may install, but some things, a lot of things will fail to install if you don't run this and use the current CRAN repository. So yeah, that's one thing to remember. After you've installed some packages, the way you want to load them in is not by using library tidyverse here in the script. Is by using this special syntax that BERT provides, which is BERT use package. And here first argument is the package name. So here I've installed NPS, which is a package for calculating Net Promoter Scores. We'll get into those in a bit. So basically the syntax here, it says load in this package, and then we can set up a shortcut so that basically the second part is similar to the Python import as logic. And then here we can set up a pattern so that only functions that have NPS in the function name get loaded, so you don't get all of the functions. So this first NPS, we'll see it here. So this is not equals r dot directly, but r dot nps dot the end. We see all the functions here have NPS in the name. Okay, we didn't load any data, so it failed. So that's the way you get prepackaged functions available from CRAN, from GitHub, wherever, to load into your Excel. And I think, yeah, to get started, this is sufficient. Now I want to go through a few examples to show you the different ways this can be used. One package that I'm using here that I installed from GitHub is the Y Finance package. And here I'm doing import Y Finance as YF. In this package, there are several functions. This disappeared. It doesn't matter. There are several functions that return an entire data frame. So you call for some data and it returns as a tidied data frame. One thing that we want to do, for example, one example that I do here is the cleanest way to use functions in Excel is several inputs but one output, as in one cell output. So here I've written several functions. Maybe we can Y Finance functions. For example, this is taking get the price, which has price and some other things, and we just take the closing price. Then we do get market cap. It gets the market cap from the same pool, and the same for the other. So let's do the examples here. R.get sector, get the Apple sector, it's technology. Pull it down, get the other ones. We can do our get industry, or I could write A2. Can do r.get last price, A2, get the prices. You can do get the last trading volume. Can do to get the market cap. Quite a big market cap, as you can see, for Apple, something around 2 trillion. And finally, we can do get summary for this one, and we can get a summary of for each company. There you go. So these can be quite long summaries. Let's try, say, maybe like this, wrap it. But yeah, quite big summaries. But so in this first example, I want to show it's quite clean cut the way it works. You can take one or several inputs. One thing I want to show you is that if you're not sure about the Excel syntax of providing input, you can do shift function 3, and then it will give you all of the attributes that you can add into a function. We can see this later, and it immediately can show you the result here to see if you're inputting correctly. So this is one input, one output. Let's see now several inputs. This are already calculated. We can uncalculate it, so we can see it. So here we want to take all of this input into one function and get one output. What we want to see here is an NPS score calculation. So an NPS score basically is probably somebody has already run this question, or some company has run this question. It's basically how likely are you to recommend the product, let's see in this example, class, service, etc. to your friends or someone like you. Different versions, but basically how likely are you to recommend this service. And the way we calculate the promoter score is we take the percentage of promoters minus the percentage of detractors, and we disregard the passives. But you see the promoter definition is very strict, so it's only people that answer 9 or 10 are counted as promoters, and all the people that answer from 1 to 6 are detractors. In Excel, we can definitely do some formula to get the percentage of promoters minus the percentage of detractors to get the final score. But why do that when you can have the logic external and directly take it from a package? So we've loaded in the NPS package. We use the NPS function. We select all of the NPS scores. Now this function gives you from 0 to 1, not from -1 to 1, not from -100 to 100 as it's standard. So we want to multiply it by 100, and we get directly the NPS score calculated for us without heavy lifting in Excel. Here I've added also a conditional format to set up to give you a visual on the value. So this is many to one, so providing an array or a vector to a function. The next point I want to demonstrate using this package is that we can do a one cell function that can populate to many other functions, basically download a data set. So here we'll be using again the Y finance functions, and we want to get all the financials for all of these companies that we have here. There we go. Can go back. So give me the financials for these companies, and I want them quarterly. So if you know by heart the argument's perfect. If you don't know, you can do Shift F3, and you can directly provide it here, for example. So we have all these stickers, and we want the report time to be quarterly. It can be quarterly or annual, and then we click OK. Now we get a 0 here, or a value. So what's okay, it broke a bit in the getting of the tickers. Let's try that again. Let's get the tickers, click enter. So we just see here ticker. Basically, in the older versions of Excel, if you want a single formula to populate an entire set of cells, not the cell in which it is, you have to use an array formula, which you do by selecting, let's say, selecting the cells you want to populate, going into the function and clicking Control Shift Enter. Now this will rerun the request. Hopefully Excel will not crash. And there we go. So basically we took all of the tickers and we downloaded all the financial data, all the quarterly financial data. So you see you have cash, assets, total assets, basically has the balance sheet, the income statement, and the cash flow statement. One issue with this is that you have to know exactly or approximately how many cells it will take, and everything that's not to be used by a function drops this ugly NA. Now this is the old version of array functions. Now I know Excel has a new thing called dynamic arrays, where you can do just simple one cell and it will automatically populate all the cells that it needs. I'm using the 2019 version of Excel, and this is available in the Excel in Office 365. So if you have such an Excel, this should not be a problem. In this case, what we can do to not have this ugly NAs, we can just select all the ones we want, go to another sheet or in the same sheet, and we can just do paste values. And there we have the data without any array issues that you will see. For example, you cannot change just one part of the array. So this, let's say, liberates the data, and we have the data pool. So yeah, I think this is good. So we went one-to-one here. We went many to many inputs to one function. We do one function to many cells. And one last thing, so we can delete this. Let's keep the array. Yeah. One last thing I want to show you is basically the way we can use. So for the inputs thus far, we've referenced individual cells. Some functions in R, especially the tidyverse group of functions, they have as a first argument the data you're working on. So now we'll see how we can provide a range, basically an X and Y range. So let's say we want to provide this A, B, and C as a data frame to be used for the function. It's not plug and play, so that's why I wanted to show this. So for such situations, BERT gives us this function, which is range to data frame, and so the selection will be the data, and then you can set whether the data has headers, so whether it's a true data frame, or whether we can set this as false to have like a matrix input into your function. So here I've wrapped the select function from dplyr to use this so we can input a data frame as an argument in this function. So it's basically the standard select. We have the data and we define which columns we want to keep. So let's use this function. We can go r.select. Now the first argument, maybe we can pull up the Excel thing. The first argument is our data here. Perfect. And then I want to keep columns B and C. So we can do OK there. We see only B here. What does this tell us? So this is an array. It's in the newer versions of Excel, Office 365, it will work automatically. For us, we have to do, whoops, not like that. So basically just pull in the area, go to the function and do Control Shift Enter. So as you can see here, basically it did the selecting for us. And in that way you can see how you can provide a selection of values as a data frame or as a matrix to any functions that you create. So I think we're done. Yeah, the important things are to set the CRAN to be this older version so that you don't have installation problems. You need to load in all the packages that you will be using for your own functions. If you want to load a package to be used directly in Excel, you would use BERT use package and set the name, the appendage to R, and which functions you want. You can define your own functions. Saving this file automatically loads the functions in Excel. And if you already have this loaded, you don't have to open this console to use them. They will be immediately available to you or your colleagues if they have it installed. We saw how to use individual functions, individual cells, a selection of cells, a dataset download, and finally that Dataframe input as your functions. I think with this you are fully equipped to take full advantage of Excel functions of R functions in Excel and really take your Excel workflow to the next level. So yeah, that's it for this video. See you in another one. Bye bye.